All right, today we're going to break down one of the biggest ideas in all of algebra, the function. Now, I know it sounds kind of formal and scary, but I promise you it's a concept you already get, and you're going to master it, all thanks to a little something I like to call the vending machine rule.
You know, when you get right down to it, the whole idea of a function is about one thing: reliability. In math, just like in life, we're looking for relationships we can trust. Can we count on getting the same predictable result every single time? That's the big question a function is built to answer. So first things first, let's get our terms straight. You've got a relation on one side. A relation is, well, it's a total free-for-all. Any connection between numbers counts. But a function, oh, that is a special, much stricter kind of relationship. It's the gold standard. It's predictable. And to get this idea locked in your brain forever, you only need to remember one thing. That's it. Just one core idea: the vending machine rule. If you can remember this little story, you'll be able to spot a function from a mile away. Okay, check this out. Imagine a vending machine. On the left, we've got a working one. You press button A1, you get chips. You press button A2, you also get chips. Is that okay? Yeah, totally. It's perfectly fine for different buttons to give you the same snack. But look at the machine on the right. This thing is busted. You press B1 and get candy. Awesome. But the next time you press that same button, B1, you get slime? No way. That's unreliable. One button can't give you two different things. And that, right there, is the entire rule. Got it? Good. Let's put this rule to the test. Let's look at our first example. What do you think? Is this a function? So here's our setup. On the left, we have our inputs, our x values. Think of those as the buttons you press. On the right, we have the outputs, the y values. That's the snack you get. So button 1 gives you a 5, button 2 gives you a 10, and button 3 gives you a 15. So here's how we test it. We just ask one question. Does any single input on the left, any single button, try to go to two different outputs on the right? Is any button being unpredictable?
And the answer is yes, this is a function. Every input has exactly one output. It's clean, it's reliable, it's a perfectly working vending machine.
Okay, let's ramp up the difficulty a little. What about this set of points? Now remember, in each pair, the first number is your input, the x, and the second number is your output, the y. So, is this a function? All right, let's break it down. First, just scan the x values, the inputs. We have a 1, a 3, and, hold on, we have a 1 again. A repeated input is a huge red flag, so we have to investigate. The first time we input 1, we get an output of 2, but the second time that exact same input of 1 gives us a totally different output, 5. And that means, no, this is not a function. This vending machine is busted. You're pushing the same button, but you have no idea if you're going to get a 2 or a 5. It's totally unreliable. I just love how this source material for this explainer puts it. Input 1 cheated. It broke the one rule it wasn't allowed to break. An input just can't be connected to more than one output. End of story. Okay, final test. And I'm going to warn you, this one is designed to trip people up, so really think about our vending machine rule. Is this set of points a function? We've got 2, 7, 3, 7, and 4, 7. So let's run our check. What are the inputs? What are the x values? They are 2, 3, and 4. Does any input value show up more than once? Nope. Every single input is unique. So what does that mean? It means yes, this is a perfectly good working function. Now, I know what you might be thinking. Hold on, all the outputs are 7. How can that be right? And this brings us right back to our vending machine. It absolutely doesn't matter that they all go to 7. Think about it. It's totally normal for 3 different buttons on a machine to all give you the same can of soda, right? As long as each press gives you a predictable result, the machine is working just fine. This is what I call the Y trap. It's so easy to see those repeating 7s and think something is wrong. But you have to remember, the rule is only about the inputs. The Y values, the outputs, can repeat all day long. It's the X values, the inputs, that are not allowed to cheat. Okay, so we can spot a function. We get the rule, but why? Why is this so important that it's one of the first big ideas you learn in algebra? Why does it matter? Well, it matters because our entire modern world is built on functions. Seriously, think about your password. The input is you typing in your correct password. The expected output every single time is getting access to your account. What if you typed in the same correct password, and one time it let you in, but the next time it deleted your account? That system would be completely broken. It's not a function. We depend on that predictability. And if you're going to continue with math, this idea is everything. Understanding functions is literally the key that unlocks the door to higher level stuff like calculus. Because calculus is all about studying predictable change, and you can only do that with graphs that follow the rules. Graphs that are functions. So from the password on your phone to the vending machine in the hall, this simple rule of predictability is running things behind the scenes. So I'll leave you with this. Now that you know the vending machine rule, what other systems in your daily life do you realize are actually functions in disguise? Think about it. Thanks for tuning in.